Okay, we're continuing. This should be the last screencast for RTI Unit 4 test. Let's look at problem number 16, or question 16. Provided is a diagram showing forces on a box. You have 40 newtons from someone pushing the box towards the right. You have someone else pushing the box with 35 newtons towards the left. Okay, what is the net force on the box? Well, you have 40 newtons to the right, 35 newtons to the left. They're in opposite directions, so you say 40 minus 35, and you get a total of 5 newtons, or a net force of 5 newtons. Now, even though this says left and this says right, this arrow is pointing to the right. So this is a force to the right. This is a force to the left. So the force that tends to push the box to the right is larger. So the net force on the box is going to be 5 newtons to the right. Okay, number 17. According to Newton's law of inertia, which of the following objects will change its motion? If it's going to change its motion, it needs something about an unbalanced force, because unbalanced forces will cause acceleration. And remember that acceleration is some sort of change in motion. It's speeding up, slowing down, or changing direction. Okay, a bike rider on a smooth and level road pedaling at a constant rate. That sounds like somebody riding at constant velocity. So it's not going to be A. A train pulling on another train, each with the same amount of force. That sounds like balanced forces, so that's not going to be it either. A chair sitting on the floor with balanced forces acting in opposite directions. Again, that's balanced forces. Balanced forces will not give you acceleration. A ball rolling across the floor with friction acting in the opposite direction. Friction is an unbalanced force, which is going to tend to slow the ball to a stop. So there is your answer choice. It's D, because the forces are unbalanced. All right, number 18. A bicycle has a mass of 20 kilograms and a car has a mass of 1,000 kilograms. A force is applied to accelerate the car from a standing position to a speed of 1 meter per second. Okay, so the bike's mass is 20 kilograms, car's mass is 1,000 kilograms, and the car accelerates from 0 to 1 meter per second. Okay, we can consider that the car's acceleration is 1 meter per second squared. If we apply the same force in both cases, so an acceleration of 1 times a mass of 1,000, force is equal to mass times acceleration. 1,000 times 1 gives us a force of 1,000 newtons. So if the force on the car is 1,000 newtons, and we're going to use the same force for both, then the force on the bicycle is 1,000 newtons also. Now, I know that the mass of the bike is much smaller, so that should already tell me that the acceleration of the bike is going to be much bigger than what I got with the car. What I got with the car was an acceleration of 1. So the bicycle should have an acceleration much larger than 1. So even without doing any math, I know I can eliminate answer F and answer G. Okay. If the same force was applied to the car as applied to the bicycle, to what speed would the bicycle accelerate? Well, we're able to get the car to go from 0 to 1. The acceleration for the bicycle is going to be acceleration equals net force divided by mass. That's a force of 1,000 newtons divided by a mass of 20. 1,000 divided by 20 gives you 50. So it's going to change its speed by 50 meters per second. And again, that should make sense because the bicycle has a very small mass, so it's going to have a much larger acceleration than the car. Number 19, if an object increases in speed, it must be the result of what? If an object increases speed, that is speeding up, slowing down, or changing direction. That's a form of acceleration. And if you are accelerated, that is because there are unbalanced forces acting. So we need to find an answer that says unbalanced forces. It's not going to be increasing friction. Friction never causes things to speed up. Okay? Air resistance is a form of friction. Again, it's not going to cause things to speed up. Gravitational attraction can cause things to speed up or slow down depending on the situation. So really the only thing that really is a good answer choice is B, unbalanced forces. Number 20, provided is a diagram showing forces on a box. We have this person pushing with 35 newtons towards the right, this person pushing with 30 newtons towards the left. Given the forces being applied from the left and right sides of the box will do what? Well, 35 minus 30, again we're going to subtract them because they act in opposite directions. 35 minus 30 gives us a force of 5. And since 35 is bigger and it's pointing to the right, we know that this box, the net force on it is 5 newtons towards the right. And that the box will accelerate towards the right because objects always accelerate in the direction of the net force. Okay, so it's not going to move at a constant rate to the left. It's not going to move to the left because we know it's going to accelerate to the right. It's not going to move at a constant rate to the right, again, because we know it's going to accelerate. And so we need to answer it with J, accelerate to the right.